All right, so today we're going to talk about what's called periodic functions. We've been working with these, we just haven't used this verbiage. Okay? Periodic functions are functions that have a repeating pattern over time. So if you look at those two graphs, it's pretty obvious which one is periodic and which one's not. Which one has a repeating pattern? The one to the left or the one to the right? The one to the left, right? I mean, the one on the right just keeps getting bigger, but it's not the same exact pattern repeated. And that's what we're going to be working with all into next week and the week after that. Okay? Well, we're going to be graphing sine and cosine. Not today. Today's really easy. Monday, when we get together, we're going to kind of introduce it and kind of get into it. Tuesday, it's going to be hard. It's going to be, okay? But we're going to do it over 2 days. Okay? Now, it appears in this picture, we're going to do a little bit of reading here. It appears to be continuing the same pattern over and over, and in fact it is. We have different ways of describing these functions. There are a few terms that we need to know. The first one is a periodic function. A periodic function, we kind of already said it, is a function that repeats a pattern of y values at regular intervals. Okay. So, again, which one of them up above is then periodic? The one on the left or the one on the right? We already said it. Is this one. Periodic. Let's put that there. And next to this one, let's put not periodic. And we're really not going to be dealing with those. I just want to get it out there what each one of those kind of looks like, whether it is or it's not. Okay? A cycle is one complete pattern of y values. So in other words, one cycle would be from here to here again. From here to here again. That would be one cycle. Or even from here to here again. Or, if I get crazy, from here to here. What I like to do is go either from top of hill to top of hill or from bottom of hill to bottom of hill to see that. We'll talk more as that keeps going. So what I want to do is mark one cycle on the graph that's periodic. So right here, let's mark the cycle from here to there. So basically circle from 0 to 2. There's one period, one cycle, excuse me. Okay? One cycle. Now, the period of a function is the distance between the starting x value and the ending x value of a cycle. So a cycle is one pattern. The period is the length of that pattern. A cycle is one pattern. The period is the length of that pattern. The pattern kind of gets, remember in geometry you're doing translations? Where you take something and you move it here and you move it here and you move it there and you can just move it all over the place. That's essentially what this is. It's taking one pattern and moving it here and moving it here and moving it here, just having it repeat itself. Okay? So let's determine what the period is of this periodic function. Well, if it's the distance between, let's underline this, starting x value and ending x value. Well, where does it start? What number is this that it starts at? 3. I'm sorry, right here, right here. Where does it start? It starts at the x value of, what's the x value here? 0. What's the x value here? So the length between 0 and 2 is? 2. Yeah, that's it. I'm not trying to make it hard. Okay? So the periodic function has a period of 2 because that's the length from starting at y value to starting y value. And the cool thing is you can do it on any, I just did it from top to top, but look here. This is from 1 to 3. Well, that has a distance of 2 as well. They should have the same period over and over and over. Okay? Now, the frequency is how often something happens per unit of time, usually 1. Okay? So per 1. Let's circle that. Per 1 of something. The frequency is really easily found. If you know the period, then you can just find it by going 1 over the period. Conversely, the period is just 1 over the frequency. So tell me, if the period is 2, What's the frequency of that first graph? That's the new bell, yeah. What's the frequency of that graph? If the period is 2, what's the frequency?
2.
Close. Look at what the frequency says in the box. 1 over the period. What's the period again? So how do I say that? 1/2. Yeah. I'm not trying to make this hard. It's literally, once you know the period, it's just 1 over that is the frequency. So if the period is 2, let's put it right next to here. Frequency equals 1/2. If the period is 4, what's the frequency? 1 over 4. It's that easy. Okay? All right. So that'll show up in the homework. We're going to kind of keep going here. The other way we classify periodic functions is through its amplitude. Let's underline that word, amplitude. Okay? Now you may have heard that word before in regards to sound waves. Science classes use this kind of stuff.
We're learning about all that
Right now? Awesome. Good timing. Graph A looks a lot like a sound wave, and you'd be correct. Use the amplitude to measure the size of a wave or its periodic function. So in science class, do you remember what an amplitude is on these graphs?
It's like between like the peak of it, like from
Yep.
the bottom to the top.
From the bottom to the top, and then divided by 2. Okay? And that's really what we got to do here. It's the same exact thing. So it's basically the distance from the midline to the top, or the midline to the bottom is really what it is, right? So the amplitude of a periodic function is, and we're going to underline this even though it's in italics, half the distance between the maximum y value and the minimum y value of a function. Now I'm going to put this in real words because I really like what Dante just said. Okay? He said it's distance between, what'd you say, highest and lowest? Is that what you said?
Yeah.
Highest and lowest points. And then I'm going to put over 2. Because really, it's the distance between the midline, which is the middle of the graph itself, to the top, and the distance from the middle of the line to the bottom. Well, that's easy. If midline, think midpoint, you always have to divide by 2 to find that. So if we did, and we're going to briefly discuss this here, but we're going to keep going here. So what I want to do here is I want to begin at a point, just complete one cycle. And it doesn't show up very well here, but one cycle, let's do one from right here. So I'm at the top of 2, going down, and then going all the way up again. And that's one cycle. Now, another cycle, I'm going to draw it a different way. Go down a little bit, zoom in a little bit more. Kind of hard to see with that color pen, so let me try a different color here. Is, maybe I start from down here. Right? Matter of fact, from down here, I start, go all the way up to the top, and then I go all the way back to where I started. There's another cycle. Okay? And another one would be, well, what if I go back here and I start right on the x-axis? Well, I go up, I go down. Should I stop right here?
No.
No, I gotta keep going until I get back to it again, so I get one entire cycle in. There's a third one. Just giving you examples of what it looks like from one starting y value to another. And the reason I don't stop right here is because the pattern didn't stop there either. It started here, goes to there. This sounds fun. Okay. Now, down at the bottom, this is the easy part. Each cycle is 4 units long. Well, look, that makes sense, right? This one starts at 2 and ends at 6. This one starts at 7 and ends at 11. So that's also 4. This one started at -4 and ended at 0. So each cycle is 4 units long in this picture. Now, that's not always the answer is 4, but in this picture it is. So the period is 4 because that's the length of that cycle. In case you haven't discovered it, and I already kind of talked about this, a real nice formula for the amplitude looks like this, and this is something you definitely want to memorize. Maximum y value. What do I mean by maximum y value? What do I mean by the maximum y value on a graph? Think about back to when we had to graph read graphs. It's the very top of the graph. right? That's what I mean by that, okay? Maximum y value is just the very top. Minus, that's a minus sign, minimum, I don't know, is that better or worse than the R&B jams we heard this morning? Did you guys hear it first thing at 8 o'clock this morning? It was like the start of an R&B song. All right, divided by, that's why this big line is there, 2, okay? Divided by 2. I don't know if you want to paint that line in a little more so you know it's a divide sign, but we're going to do examples of this in a few minutes. And the period you can find real easy by just taking your ending x value of a cycle minus your beginning x value of a cycle. So, like I said, we knew that this was 4 units because really I could go 11 minus 7 is 4. I could go 6 minus 2 is 4. I could go 0 minus negative 4 minus negative would zip zap, I get 4. Okay. That's how we can do it. Or you can just count the number of spaces between the beginning and the end of it. Okay? Let's go to the next page. This is really an introduction to what we're going to be doing going forward. Okay? Alright, so what I want to do is I just want to find what is the amplitude and what is the period for each one of these graphs. I'm going to tell you they are all periodic. Okay? Not all the patterns look exactly the same, but they do repeat themselves. Like even for C and D, like look at this one. If I start here, kind of down, weird, down, then up, and down, weird, down, then up, and it recovers the same pattern over and over. Can anybody tell me the amplitude on that first graph? 2. Why? You're right, the answer is 2. You don't know how to say it. Anybody know how to say it? The amplitude measures, go ahead Tori, what do you think?
Amplitude measures height and up 2 on the y.
Yep.
That
And?
would be 2. Oh, and it's
Down
down 2.
Now here's the thing, it's really easy if it's split up in the middle, right? But this one's not split up in the middle. So the midline for this is this line right here, and it goes 2 up and 2 down, so yes, the amplitude is 2. Here's how we can always do it right. It is the maximum height, which is 2, minus the minimum. What's the number for the minimum here? Close. Negative 2, right? Because it goes all the way down to negative 2. Divided by 2. What happens when you got minus and negative next to each other? Zip zap. If you don't know zip zap, that just means plus plus. And I get 4 over 2, which is like Danielle said, 2. Okay. So we could always, if we can't see, like in the next one, I'm going to talk about it briefly, it doesn't work out as perfect, but the height, the highest point minus the lowest point divided by 2. So, the period. The period is from beginning to end of this pattern. And let's just start it here at 0. Where does it end? Does it end at 2 or does it end at 4? That's the question. Why is it 4?
You mean like the whole like?
Yeah, that's kind of what I'm trying to get at. Actually, you're answering the question without even knowing it. The whole cycle goes up and then down and then starts again. Can you see that? If you start from left to right, it goes up, then down, then up, then down, then up, then down. So we could really measure this from multiple different places. I can measure from here and go up, then down, then back to here. What's that distance? 4. And that is my period. Now say you don't like to start in the middle. Say you want to start at the top. Look, right here. If I start at the top there, and if I start at the top there, well, from there I go down and then all the way up to the top again. Well, that goes from negative 3 to 1, which is a distance of 4, right? It's not that hard, is it? Like even the bottoms, look, negative 1 to 3. Sure, those are 4 apart. It should always be the same distance, okay? Frequency. What's the frequency? I actually said 4 earlier. What's the frequency? 1 over 4. Literally, the frequency is 1 over the period. And so if the period's 4, it's just 1 over 4.
So that's every time?
Every time. Okay? Alright, now that we got kind of warmed up a little bit here, what's the amplitude on B? Well, what's the highest point on B?
2.
Careful.
Wait. Oh yeah, it's not 1.
Right? That number is 2, but it's already 1, right? So 1 minus, what's the lowest point? Close. What is it?
-1.
Negative 2. That's what I was trying to say. People said 2 and it's just negative 2, right? So minus negative 2 divided by 2. So I zip that and I get 3 over 2. What's 3 divided by 2?
1.5.
1.5. Can I write 1.5? Is that okay?
Yes.
Yeah. It could be a decimal. That's okay. It's 1.5. What's the period? Don't say it out loud. See if you can figure it out. Based on what we said in the previous example. What's the period? See if you can figure it out real quick. Give you 10 seconds. What do you think? 3? Tori, can you go up and show me how you did it? You got it right. It is 3. Can you show me what you measured from where to where? To get 3? Can you show me right now? Just show me what you did. Where'd you count from where to where to get 3? Yeah, that's it. Okay? Look, here's what Tori did. He just counted from here to here. Did anybody else count a different place? So Tori counted from here to here, and that distance is 3, and that is right. Did anybody count in a different place and still get 3? What I'm trying to say is, guys, I could count from here to here and get 3. I could count from here to here and get 3. It doesn't matter where you count from. It's just counting from either peak to peak, or low to low, or even middle to middle, right? And the distance is 3. That's right. Okay? So what's the frequency? 1 over 3. Okay? I want you guys to try the other two. Try C and D a minute here. Take a few minutes, try C and D. And if you're stuck, stop me as I'm walking around. Maybe compare it with the neighbor. Are all of these values always going to be positive? You're ever going to get a negative amplitude or period?
Because there's actually lines.
Anybody? Are you going to get a negative period or amplitude ever?
No.
No, because we're talking about distance, right? If I drive to the other side of town and I go reverse the whole way, it's still a positive distance, right? So it's always going to be positive. So if you end up getting a negative answer, you probably did something wrong, okay? Gotta be kind of careful here, right? Some of the numbers are kind of in between.
You can leave like that, right?
Mm-hmm.
Or
What, sure.
yeah.
All right, so I'm hoping that the amplitude is the easier of the two, right? Look at the highest point, look at the lowest point. But the period sometimes isn't, because you got to look at where does it repeat. What do you think would be the easiest thing to measure in terms of period on part C? Right, the peak to peak, right? Because it has multiple maximums, local maximums, but the highest peak to the highest peak would be the easiest thing to measure. So what is the period on that problem?
5.
It's 10. Here's why. We don't divide by 2 with the period. We divide by 2 with the amplitude. Okay, so let's look at it. From here, the highest point to the highest point. It's 5 dots, but the graph's going up by 2s.
Oh.
Right? Okay, so if you had 5, that's why it's 10. Okay, because it's going up by 2s. Which actually, I think the next one is too, right? So you might want to double check your period real quick to see. Because if you're going up by 1s, that's a different story. So again, if I go from highest point to highest point, what's the distance? 6. It's 3 dashes, But it's actually 6 because it's 1 up by 2s, right? Yes, I was trying to get you. What's the frequency then for this one? 1/10. And for this one? 1/6. Simple as that, right? All right, what do you think? Did any of you, I went from peak to peak, did any of you go from a different spot to measure your period? Any of you go like from bottom to bottom? Like could I? This would be 5, this would be 15, it'd still be 10. Even if I went from this, from 2 to 12, right here, so 2 to 12, it's still 10. So again, it should always work that way. Let's go down below. Now, this is where it's a little unique. Okay? For everybody, it's going to be a little unique. What I want you to do is sketch your own graph. I'm going to do the first one with you, so you kind of get what's going on here. What we want to do here is sketch your own graph, and your graph can be any shape you want, but it must have the following things. I must have a period of 3 and an amplitude of 4. So, with that being said, if the period is 3, how far away are they going to be left to right? 3. If the amplitude is 4, how far are they going to be away up and down? Here. Well, I like what you're thinking with the amplitude. What do we do to find the amplitude again? We go high minus low divided by 2. So what that means there for this problem is that high minus low divided by 2 equals 4. To solve this, if I times both sides by 2, then the high minus the low better be 8 apart. Now, I don't need you to do that math in this problem. What I'm trying to explain to you is, if the amplitude is 4, that means from the highest point to the lowest point, I can subtract those and then divide by 2 and I get 4. If I only had the highest point and the lowest point 4 apart, 4 divided by 2 would give me 2. Right? So you were going the opposite way is what I was trying to say. Okay? So let's, just for this one, I want you to draw what I'm drawing. What I'm going to do is I'm going to start here and here. So my lines, you can see I'm going to do the same thing on the other side. I'm going to put one here and one here at 4 and at -4. Because then what I'm doing is I'm ensuring that I'm going to put dots all along that line. I'm going to put dots all along this line. Then I'm ensuring that my amplitude is 1, 2, 3, 4, 5, 6, 7, 8 apart, and 8 divided by 2 gives me an amplitude of 4. So we're good there. Now I'm just going to start putting points. You can put them wherever you want if you want, except they have to be how many apart again? 3. So I'm going to put a dot, and then I'm going to count 1, 2, 3, and put a dot. Then I'm going to count 1, 2, 3, and put a dot. 1, 2, 3 is off the graph, so I'm not going to worry about that. What can I not do down below? I can't put it right below it. Because what would that graph look like? It would go, which doesn't happen in the real world. Even a heartbeat machine that you see stuff like that, where it kind of goes up like this and then kind of goes down, it still has a slight decline. It doesn't go straight down. Okay? So what I want to do is I still want to do numbers that are 3 apart, but not start there. Let me just start here. Right? Dot, 1, 2, 3, dot, 1, 2, 3, dot, 1, 2, 3, dot. How do I finish it? Yeah, just draw, right? Draw the loop, right? So I'm going to be a little closer to the edge here, and then a little further away, then a little closer, a little further away, a little closer, a little further away. And before anybody judges my drawings, I'm going to come around and see if you drew it as straight as me. No? Better not look? Okay. Do you get the idea, though? What we're trying to accomplish here. We know the points from top to top have to be 3 apart. Not from top to bottom. The bottom to bottom have to be 3 apart. The top to top have to be 3 apart. And then we got it. And the amplitude, again, really, if you're thinking about the distance, it's going to be twice what the amplitude is. Okay? Any questions on what I just did? Because I want you to try the next one. Draw your own. Look at what I did. Use mine. With a period of 4 and an amplitude of 2. I'm going to do my own. I'm going to freeze it so you can't see. I'm going to do my own, and I'm going to promise you it's going to look different than probably most of yours. Does it have to be curved? No. It can be straight lines if you want. Okay? It can be jagged lines if you want, just as long as you make the same exact pattern. Right? If I look at C and D, I can see that. All right, go ahead. Try and draw your own with a period of 4 and an amplitude of 2. Anybody confused? Want me to see it?
Oh, okay.
Okay, here's the key. Look at your graph. Is your peak to peak 4 apart?
Yeah.
Is your bottom to bottom 4 apart? Is your distance between your highest point and your lowest point 4? Because that's what it should be. Okay? Why? Because if I take the amplitude and divide it by 2, or take the distance and divide it by 2, I get the amplitude of 2. Right? So, let me show you mine. And again, it's going to probably look different than yours, and that's okay. The key is, your point's got to be 4 apart in the x direction, and your point's got to be 4 apart in the y direction to give me an amplitude of 2. Because if they're 4 apart, I divide it by 2 to get the amplitude of 2. Okay? Now I moved mine way up on the graph. It's not right in the middle. You could do yours in the middle. You could do yours down way below. You could do yours wherever you want. It's your graph. It's your world. I just want to make sure you're doing the right thing. How are we feeling? Because that's it. Okay, we got about 15 minutes left. I'm telling you, in 15 minutes you can finish this assignment. Because there's 2 pages. There's a front and back. The back is just to graph a couple more of those sketches. The front, you could finish that entire front page in 5 minutes if you really settle in and do it. Okay? You can get decimals as answers for both the period and for the amplitude. So if something looks like it's in between, just write it as a decimal answer.